Hello fellow problem solvers. So today we're going to be doing a problem from the 2019 IMO, problem number 5. I suggest you try this beautiful combinatorics problem out for a minimum of 45 minutes. Ideally an hour and a half to 2.5 hours, maybe even 3 hours, not more than 4.5 hours, given you wouldn't have that much time at the IMO anyway. So this is a problem that you should try out, especially if you're like decently okay with your combinatorics abilities, maybe not too much. I really enjoy. I think this is a beautiful problem, a very nice one. So if you want to go ahead and solve along with us, I suggest you pause for 10 minutes, read the problem, and understand what it's about, and then put your first ideas out on paper. So now let's begin that. What do we have? We have this Bank of Bath. Okay, the IMO was in the United Kingdom, in Bath. That's why there's the Bank of Bath. It's useless. With every coin has an H on one side and a T on the other side. Okay, heads or tails, right? So Harry, we don't care, has n of these coins arranged in a line from left to right, and he repeatedly performs an operation. Let's see what operation this is. If there are k greater than 0 coins showing heads, then he turns over the kth coin from the left. Otherwise, all the coins are T and he stops, okay? So now we have an example of this process. Okay, so we have one coin, then we're going to have 2 coins of heads, so we're going to turn over this one, and then we're going to have one, we're going to turn over this one, and then we get all tails. So now we have 2 parts. One is to prove that this process always terminates, no matter the initial configuration, that it will always terminate. And the second thing is, if it takes, like every single one of these, will take a couple of steps to terminate, and we need to find the average number of steps it'll need to take over all of the different possible beginning configurations. So, what is the first thing to do in this huge problem? Well, for me, I don't know how I'm going to solve this. How do I find that there's that it will terminate after a finite number of steps? There is no periods, but I'm also looking into B. I need to find the average. So what do I do for the average? I invite you here, pause for a minute, ask yourself, how are you going to sort of start this off? And the answer for me is I'm going to play around with smaller cases. Let's do n equals 1. We can have tails, in which case L of tails is 0, or we're going to have heads and then go to tails, in which case the L of heads is equal to 1, so the average is equal to 1 over 2. Yay! So now let's go to n equals 2. And I'm legitimately just going to write these out. And I invite you, if you haven't done so, pause for 20-30 minutes and write out a couple of these cases, because that's what we're going to be doing now. So let's do n equals 2. What can we have? Tails, tails, tails. The L of that is going to be 0. We can have, so what gets us to tails, tails, tails? Well, if I only have one head before that, and it's here, so then I'll get to tails, 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 and the L of heads, tails is going to be 1. And is that the only thing? If I have 2 heads, then I'm going to get to heads, tails, right? So L of heads, heads is equal to 2. And if I have a tails and a heads, I'm going to get to this one. And the L of that is equal to 3. So here we have 0, 1, 2, 3. 0 plus 3, 1 plus 2. It's going to be 3 over 2. And now we're going to do n equals 3 here. So I have this for n equals 3. And this is actually the first time I'm getting like something can be like heads, heads, tails. I can get to that from 2 different ways, right? Either from triple heads or from 2 tails and a head, which is new, right? This wasn't a thing that happened here. It was just like I went up. And now this is for n equals 3. And my question for you is, do you notice any patterns? Anything from here that's the same here, or any sort of pattern? Do you see anything that you can use that can sort of tell you a hint as to what you should do in the problem? And for me, it's been a long time since I've solved this problem, And I forgot, I actually don't know anything from here. Can I use any sort of pattern? So what am I going to do? N equals 4 is what I'm going to do. Yeah, I know it has 16 different possibilities, but maybe while doing those 16 possibilities, I'll get to something. And also, before I do that, like, what's the average here? It's 0, 1, 2, 3, 4, 5, 6. 0 plus 6, 1 plus 5, 2 plus 4, 3 and 3. So the average here is 3 for n equals 3. Here we had a 3 over 2, a 1 over 2, now a 3, which is the same as 6 over 2. So 1 over 2, 3 over 2, 6 over 2 plus 2 plus 3. Maybe it's something like that. Maybe it's n times n plus 1 over 4. Maybe that's the result. We don't know. But it doesn't matter at this point. We still haven't proved part A, but we're going to do them both at the same time. Maybe we can use some induction here. So, for n equals 4, and I'm actually going to do this live on camera to see, okay, the ending is tails, tails, tails. Let me do one of these. So let's say, so here the ones with the longest one was a tails, heads, heads. Maybe here's it was tails, heads, here's it was heads. So maybe if I have a tails followed by all heads, that will be very long. So let me actually, tails follows by heads, 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 triple heads. Well, actually, wait a second. Heads, tails, and heads, tails. Actually, tails, heads followed by tails was shorter here. Heads, tails followed by tails because this tails was never really used. And that this tails was never really flipped, this tails was never flipped, this tails was never flipped. And we had the same thing we had beforehand. Could that be interesting? Maybe. We don't know. We're going to see if that is a pattern. And the rest of it, though, just before I go ahead, is going to be, so we had triple heads and then a heads, tails, 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 heads. We always had an H at the end. And it's only after we got rid of this H that we could go ahead and get rid of all of them. Yeah, because when you get rid of this H, then it just like crumbles down. So maybe a thing is like if we have an H here, then we will get to first this one H, and then from tails, we might finish up inductively or something. So actually, well, what did that look like here? So here, and we came to a 3. I really am not sure if this is correct or not. It's just, what am I seeing? Like, what patterns am I seeing? How am I connecting this to this? Like, I'm also seeing, like, it's also a tails here at the end, and I get a heads and a tails. And it's the same sort of thing. Like, these problems, these competitions are, actually can be very much about pattern recognition. Do you recognize any patterns that you've seen from the smaller ones to the bigger ones? That is what it's often about. So now let's do this. Tails, tails, tails. Okay, I'm starting off from this. So I have 1, 2, 3 heads. So this one's now going to be head, tails, tails, heads. Now I have 2 of them. Now this one's going to change to tails, 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 heads. And now it's going to change to heads, tails, tails, heads. And now heads, it's interesting, heads, heads, tails, heads. And now 4 heads. Oh, 4 heads. So now I have this, and from here I get to a heads, 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 tails. And then it's the heads, 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 that's the triple heads. Then I can guarantee you now that from here, L is going to be free without even knowing it, because I'm no longer counting this T. And so I'll be good, I'll finish up. Yeah, I'll finish up like that. Now the question is like, how do I finish up on the other ones? Right now, this one is going to go to, oh yeah, heads, heads, tails, tails, and then heads, tails, 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 and then bam, this. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is 10 of these. Okay, I've captured a fair amount of them. Though here I had, so here where I had heads, heads, tails, I did not have tails, heads, tails, tails, right? That was not what I had here. So I'll also have tails, heads, tails, tails, and that will also transport me here. Same thing I had before. Now I'm curious if that's it. Can I get to this one? So what are we missing? We have, with tails, we have, okay, let's maybe look at with the heads being first. I have this, 2, 3, 4, 5, 6 of them. Now, which ones am I missing is a question. Maybe let's analyze. The T is here, and then it all goes down that route. The T is the ending one. So which one? I have 1, 2, 3, 4, 5 tails. So I have 4 tails. Do I have tails and all heads? I have tails, head, head, tails. So I have head, tails, head, head, tails. What is that giving me? Tails, head, head, tails. It gives me 2 heads. It gets me 2 tails, tails, heads, tails. So tails, tails, heads, tails. No, I don't have it. And then I get from to that to heads, tails, heads, tails. Again, I don't seem to have that either. It's the opposite of this. It's mirror image. Maybe that's got something to do with something. And then does this give me two of them? Triple heads and a tail. Do I have a triple heads and a tail? I have 2 heads. Yes, I have a triple heads and a tail. It's right here. So interesting. And this gives me 1, 2, 3. So I've got 1, 2, 3, 10, that's 13, 14. It's an interesting thing now that I'm having. Like, what is it? Can I go backwards is another question I'm asking myself, because I sort of lost count of which ones I have and which ones I don't have. 7, and now, actually no, this is 4, 5, 6, and this is 3. So now here's a place for you to stop and try to finish this up yourself, right? And then pause for half an hour literally now and see, is there a pattern that you notice that you could use or something that we could prove? Pause now, and here is the next step. So now notice that after I've actually paused, I've noticed this big pattern, which is the same as this, just with a T added at the end. And once I think about it, it makes sense that if I've had a pattern here, if I just append a T to the end, nothing would change, right? The T would never be touched, right? Because unless it has 4 H's, the last one only gets touched when you have 4 H's. So when you get to 4 H's, the last one gets touched, and then you move into this position, which is a position that's in the middle here, right? It's here in the middle. So it feels like there's something there. Like this is a 3, and it's been 0, between 0 and 6. Here it's at 2. It feels like I'm very, very close here. And the answer is, if the answer is n times n plus 1 over 4, then we get the answer. We get a 0 and a 10. We can pair them up, a 3 and a 7 here, a 4 and a 6 here, a 5 here, a 3 and a 7 here, a 4 and a 6 here, and a 5. So there seems to be some pairing up. And now what I'm thinking about is, what is this thing right here that I have? And if you pause and think about it, this also looks like this in some weird way. Because I'm also getting, let's call this the end. Then I get bam, 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 bam. It's the same thing. The patterns are the same. and they're building up. So the question is, how do I get to this pattern? What is there's like, it seems like we're building up this like tree, boom, 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 boom. What is it? How do we prove it? What is the connection between these two? That is the question. What is the connection, right? So here I'm looking at a triple T, four H's. I have an H and two T's. I have three H's and a T. How are these connected? Like, question is, how are these connected? If I look at the last one, it's going to change when I have the four H's. How is this the same as this? Do I maybe need to flip something, right? If the H is here turned to a T, right? If every H is a T, then this becomes this. Okay, now we have HHT, that would give us a H, this code, we have a TTH. So just flipping them doesn't work. Maybe flipping and rotating. What if we do that? What if we flip and rotate? If I flip, then it's heads, tails, heads, and rotate, it's still heads, tails, heads. Okay, so we get flipping works here. What about here? So now we're at flipping and rotating. That's our hypothesis. Just flipping them didn't work. Maybe flipping and rotating works. Does it work or not? I don't know. I'm just trying to figure out what this pattern is that we're seeing here. So heads, tails, heads would be tails, heads, heads. And when you flip it, it would be, so actually flipping it would be heads, heads, tails. So I need a heads, heads, tails. Okay, that's encouraging. I maybe was lucky. Three tails, three heads, boom, boom, boom. Heads, tails, heads. Flipping doesn't change anything, so it's heads, tails, heads. Okay. Now flipping is important because we don't have symmetry with respect to this one. So it would be first heads, tails, tails, and then flipping it would be tails, tails, heads, tails, tails, heads. Whoa! And finally, now tails, tails, heads. Flip the signs, heads, tails, heads, heads, tails. Now flip it, tails, heads, heads. Tails, heads, heads. What is this? When I saw this, now the question is, can we prove this is the case? Does this work for 5? And you can maybe check it if it works for 5 as well. But for me, when I saw this, I was like, what magic is this? Right? What's happening? And also an important part here is to note that our induction here would mean that once we get to A, that the 4 is the same as a 0 here, right? So we are adding n, and then, so for half of them, it will be the same as it was before, which is n times n plus 1 over 4. And for the other half, it takes a 3 when you have n. When you get to this one, it takes 3. So it's the 0 plus a 4, which is plus n. So every one of them will add n to them. And the average for every one of them is also n plus 1 over 4. And you add n to every single one of them. So actually, the average is going to be, the average of these will be n times n plus 1 over 4. We're going to do over 2. So this is one average. And the average for these here will be n plus 1 over 4 plus n. So it will be something along these lines. I may have messed the algebra here. I may have messed up the algebra. So this is n times n plus 1 over 2 plus 2n over 2. I've messed up the algebra somewhere. Yeah, we'll figure it out. Actually, it's n plus 1. It's 2n plus 2. This is n plus 1. Like, this is if we're going from n to n plus 1. Yes. This is if we're going from n to n plus 1. So now this would be, and then everything over 2. And so the average would be n plus 1 times n plus 2 over 4. Okay, so now I'm getting more confidence that this is actually correct. The answer looks nice. It's an IMO number 5. It's a doable problem. Now, what are we trying to prove? Let's clear this board and then see if we can prove it. So we're trying to prove a couple of things. We're trying to prove first this symmetry once we add AT. That thing isn't difficult. That is pretty obvious because T doesn't do anything. The difficult part is like this sort of a situation that, like, what the hell am I doing here? Is sort of my thinking. I'm flipping their signs and then I'm rotating them. So what is this thing that I saw now? That we saw together. What is this thing we saw? How do we transform this into something mathematical that we can work with? And now the thinking is, okay, so if I have a sequence, heads, tails, let's do tails, tails, heads, and then a heads. What is the action? Like, I'm now looking at this once I rotate. So what happens when I change? If this had k minus 1 heads, say we're at n, right? Then when I flip all of these, I'm going to get n minus 1, then minus k minus 1 heads here. So that's going to give me n minus k heads on this side. And then when I flip them, I'm trying to show that it's the same thing that I had in the I'm trying to show that the number, that the thing that I get after I flip these, the distance for that number to heads is the same, for all heads is the same as it was for all t's here. And now I'm going to actually invite you here to pause for another 10, say 10, 20, maybe even 30 minutes, because I also think about this, and I invite you to pause and think about this too for the next 10, 20 minutes, okay? So now with that, here is the next step. And here's the next step. What I want to do is I want to show that when I apply this operation, right? When I take these numbers, I flip them, and then I rotate them, then I'll get the appropriate number here. Now, what is enough for that? Well, it's enough to show that once I do that operation here, and if for each AI, let's define this like the opposite of AI is how I'm defining it here, is equal to, or actually maybe, yeah, the opposite of AI will be equal to what's called tails if AI is heads, and heads if AI is tails. So the opposite. That's how I'll define it. So what I want to show is that when I apply this operation, and I have k minus 1 h's here, and what will happen here is after doing this operation, I'll go to A1, A2 till not AK plus 1, AN minus 1H. I'll get to this one. Now I want to show that once I apply the operation and I switch them around, that I'll get really the same thing, that this thing that I get here, which corresponds to something on this side, on the smaller case, for n minus 1, will map to the same, will go to the same thing that this maps to when I apply the same operation. And if I do that, then I've really proved that, I've proved a couple of things. I've proved that if there's an H, that there's a correspondence between these. And so I've sort of, with that I sort of get to these, I prove that I'll get to these 4 H's, because I'll get for n minus 1 I'll get to n H's, because I'll get to n minus 1 H's sort of inductively. Actually, I'll get to n minus 1 T's inductively. And with that, I know that when I get to n minus 1, that when I get to n H's, I know I have n more steps remaining. And then from there, I can finish up the problem. So now we're going to be proving that. So what do we get when we flip this around? So we first flip them, so they're going to be not A1, not A2, not all the way till not AN minus 1. And then I'm going to have them flipped, and it's going to be not AN minus 1, not AN minus 2, all the way till not A1, H. Now what this thing right here would flip into, this segment here, would flip into what? Well, I have how many? Because I had a total of k minus 1 h's. When I flip them, I have n minus 1 here. I'll have n minus k h's here. And I'm ignoring this one now. So now when I take the next step, ignoring the h, I'll sure get the h here. That's to append. But what I'll get here is I'll get, again, not A1, all the way till, actually this is not AN minus 1, all the way till the n minus kth one, because AN minus 1 is the first one, AN minus 2 is the second one, n minus k is the n minus kth one, and what is that? That is AK. So I'll have AK will be OK, and every other one of these will be not A1, not A2, not AK minus 1, not AK minus 2. Now the question is, does this transform into this once I do the flipping? And the answer is yeah, it does. Because, and why is that? Well, it's because, what's it called? When I flip all of these, when I flip all of these, I'll have not A1, not A2, except not AK. AK will be AK, and then I'll flip them and I'll get this ordering right here. So there is this correspondence that we've seen before, noticed before, and with that we know we will get to, because this sequence without the H will get to a, what's it called, all T's, like we'll get to n minus 1 T's. So that means that here we will get to, and this corresponds to us getting to all H's. And then once we get to all H's, then we just need, and then we're n steps away from getting to all T's. And this then shows our recursive formula actually works out. And with that, we prove both parts A and B, right? We've sort of found for part B, like what we're showing here is that if the average is going to be, if the average is, what is this called? I think ln. Let that be the average. We get that ln is equal to ln minus 1 plus ln minus 1 plus n over 2. And this gives us inductively that ln is n plus 1 times n over 4. And then this, finishes up the proof. Why is it, like, why does it immediately finish part B? Part A, because if one of them didn't reach 0 after a finite number of steps, it's else L of that C would be infinity, and then the average of all of these could not be a integer, right? It could not be a natural number because LC is between 0 and infinity by definition here. It's a non-negative integer by definition. So this finishes up the problem. And what I really, really loved about this problem was it's sort of how it builds up, right? Now that I've solved this, I can sort of write a computer program that, I don't know, it's like fractal. I don't know if it's maybe not the most precise thing to say it's fractal-like in nature, but it feels like, I take this and then like, boom, a new universe opens up. And I think that's pretty cool. So this finishes up our problem, and as always, thanks for problem solving.